Okay, welcome to another lesson in geometry. Today we are covering section 3.7, equations of lines in coordinate plane. So these last two sections are very much a review of your algebra understanding of lines, okay? All right, so let's take a peek. Write T for true or F for false. An ordered pair describes the location of a point in a coordinate grid. This is true. Number two, an ordered pair can be written as x coordinate comma y coordinate or a y coordinate comma x coordinate. This is definitely false. There's only one way to do it, and it's the x, y first. That's why it's called an ordered pair, because the order of the x and y matters. It tells us what to do. X is the left and right, and y is our up and down. Okay? So the ordered pair for the origin is 0, 0. This is true. The origin is the center point in our grid. It's where we begin our graphing from. So this is point 0, 0, and its special name is the origin. It's where the x and y axis cross. Okay? So we have vocabulary builder here, slope. The definition of slope of line M between 2 points x1 and y1 and x2 and y2 is the ratio of the vertical change to the horizontal change. So the vertical change is the up and down, so that's why we use the y subtraction up top. And the horizontal change is the left and right, that's why we use the x coordinate subtracting for the bottom. And it's rise over run, okay? Now remember, it doesn't matter which point you pick to be x1, y1 or x2, y2, you just need to be consistent in the ordering that you put in your slope, okay? All right, so complete each statement with the appropriate word from the list. Use each word only once. So the blank of the hill made it difficult for the bike riding. So this is the slope, okay? The driveway sloped down to the garage, or the driveway sloping. That's not going to make sense. So this is sloped down to the garage. And then the sloping lawn, this is an adjective here, describing the shape of the lawn, led to the river, okay? Draw a line from each word in column A to the corresponding parts of speech in column B. So a line is a noun. It's an object, okay? And linear is an adjective. It describes the way a graph looks. A graph could be linear if the graph looks like a line. The line is a noun. That's what the graph actually is. All right, let's flip it over and look at page 2. All right, finding slopes of lines. Use the graph at the right. What is the slope of line A? So line A is this blue one right here. We're going to find the slope of it. And let's think about this. So I know the slope is a ratio of the change in the y coordinates to the x coordinates. This is the formula that says that. Remember, m always takes the place of slope. 2 points that lie on line A are 2, 3, and 5, 7. Those are right here, 2, 3, and 5, 7. Okay, so we can transfer those into our formula. So remember, we could say this is point 1, so that's x1, y1, and this is point 2, so that's x2, y2. We put the y2 coordinate first, which is 7, and then the y1, which is 3, and then that's over top of 5 minus 2. Now remember, it's okay if you call the first one x2, y2 and the second one x1, y1. We would just have 3 minus 7 over 2 minus 5. They'd both be flipped around. So here, 7 minus 3 is 4, and 5 minus 2 is 3. So this has a slope of 4/3. Now this is great. This is a number that describes the steepness. Number that describes the steepness of the line. Okay, now we can also see this number pictorially in our problem up here. If we go from 2, 3 to 5, 7, that requires us to travel up 4 and over 3. So the slope here is up 4, the change in the vertical, over 3, the change in the horizontal. Okay. Remember, lines that go uphill from left to right are positive, and lines that go downhill from left to right are negative. Okay. All right, key concept, forms of a linear equation. The slope-intercept form of an equation of A is y equals mx plus b. Okay, this is going to be important. You got to remember this stuff from Algebra 1. Remember, the m is our slope and the y-intercept is our b. So it would be something like this. Where it crosses here is b. And then this ratio of up and over is the m. Okay, Together, the up divided by the over makes the m. Okay. All right, and then we also learned one called point slope form, which was a good way to get an equation if we knew the slope in a point. We could just plug it back into this. All right, so we took our coordinate and we took our slope and plugged them in. So remember the x over here and the y over here make the coordinate. It's always x minus the x coordinate and y minus the y coordinate. So it's tricky to remember what to do with the negatives there. Okay. All right, so let's take a look at a little practice on this. Graphing lines, graph y equals 3x minus 4. And what form of this equation given? So this is slope-intercept. That's our slope, and that's our intercept. Okay. So written as a fraction, the slope is 3 over 1. And the 1 point on the grid we know is the y-intercept, and the y-intercept always has a 0 for the first coordinate, so 0, negative 4. So from that point, move, let's see, 3 units up and 1 unit to the right. So let's graph this. So we go to 0, negative 4. That's right here. That's our starting place, the y-intercept. Okay. And then from here we can count up 1, 2, 3 units and go 1 over. Or 1, 2, 3 units and go 1 over. Or 1, 2, 3 units and go 1 over. Okay. If I connect them, I get this line. So this is y equals 3x minus 4. So problem 3, write the equations of lines. So what is the equation of a line that has the slope of negative 1/2 and a y-intercept of 2? So this is our m and this is our b. All right, so the m is negative 1/2 and the b is 2. So we're going to write the equation of the line, and we're going to use y equals mx plus b because we already know the m and the b, so why make it hard on ourselves? Okay, that's called the slope-intercept form. So we're going to do y equals negative 1/2 x plus 2, and we are done. All right. Now, what if we were given 2 points, just negative 2, negative 1, and 3, 5, and we were asked to find the equation of this line? Now, obviously, this one doesn't cross evenly through the y-axis, so it's very hard to guess what the y-intercept is. Okay. All right, so there's one way we could do this. We could just find the slope. So it says on here, you can use the 2 points to find the slope. So I'm going to do that 2 different ways. I'll go from this point to that point. That's 6 up and 5 over. So my slope could be 6 over 5. I could also use the equation. So we could do the change in the y's, 5 minus negative 1, over top of the change in the x's, 3 minus negative 2. That's 6 over 5 for our same slope that we got by looking at the picture. Okay. So then we could use point slope form and let's see, 3, 5 to help us write one way. So we could say y minus 5 equals 6/5 times x minus 3. So that's what this part here is. Okay. But we're asked, well, what if we wanted to use the other point? Instead of 3, 5, we use negative 2, negative 1. How would we do that? Okay, well, first we would write it in point slope form. Okay, and then we would substitute in for x and y, x1 and y1. So in place of y1, we put negative 1, and in place of x1, we put negative 2. Notice we still have the subtraction there. And then we'd simplify. Y minus y1 would be y plus 1. And inside the parentheses, x minus negative 2 would be x plus 2. Okay? All right, so number 18, we're asked to show that, hey, we wrote 2 different lines. We wrote y plus 1 equals 6/5 times x plus 2. And we wrote y minus 5 equals 6/5 x minus 3. And we want to show that they really are the same line. So what we're going to do is we're going to convert these into slope-intercept form to show that they work out to the same thing. So first we would multiply the 6/5 in. So that's 6/5 x minus 18/5. Okay. And then I'd subtract 5 from both sides. So that's going to be 6/5 x. And 5 is the same as, let's see, we want a 5 on the bottom, so 25/5. So negative 18 plus 25 is going to give me 7/5. All right. Then we could do the same thing over here. Y plus 1 equals 6/5 x plus 12/5. 2 times 6 is 12. Keep the 5 on the bottom. And then I'm going to subtract 5/5 to both sides because 1 is the same as 5/5. So the like terms will put the two constant parts together. 12 minus 5 will give me 7/5. And we can see that we have the same equation now, much easier. Okay? So underline the correct words to complete each sentence. The equations are the same. Choosing -2, -1 gives the same equation as choosing 3, 5, because these equations are equivalent. This, because they're written different, this is 3 different ways to write the equation in the same line, doesn't mean they all don't make the same line. All right, let's flip it over, look at our last question. Okay, so writing equations of horizontal and vertical lines. So what are the equations for the horizontal and vertical lines that go through 4, -3? So first let's mark 4, -3 on our grid. It's right there, okay? So every point on a horizontal line that passes through 4, -3. Well, let's draw the horizontal line to see what we're talking about. So here's our horizontal line. And all of the points on this horizontal line, let's name a couple so they see what they're talking about here. So we already know 4, -3. But we also have 5, -3. We also have 2, -3. We also have 0, -3, and -3, -3. And we can see a pattern here, and this is what they're trying to tell us, is all of the points, okay, are -3 here for the y coordinate. So every point on the horizontal line through 4, -3 has a y coordinate of -3. That's true. All right, so the equation of the vertical line through 4, -3. Let's see what the equation should look like for the vertical line through here. So our vertical line goes this way. Okay, and notice for the vertical line, x, y, we always have 4. So we have 4, -3, we have 4, -2, 4, -1, 4, 0. That's all of these points, okay? All right, so in this case, the x is always 4, okay? Always 4. So this is definitely not our equation for the vertical line, okay? That's the equation for the horizontal line. So the equation of the vertical line through 4, -3 is x equal to 4. That's true. And then it says graph the horizontal and vertical lines in the coordinate plane at the right. So we already did that, but let's label their actual equations. So this guy's equation is y equals -3, because the y values are always -3. And this guy's equation is x equals 4, because the x coordinate is always 4. All right? Okay, lesson check. A classmate found the slope of the line passing through 8, -2 and 8, 10 as shown at the right here. Describe your classmate's error and then find the correct slope of the line passing through the given points. So let's see, they put the x coordinates on top. So their error was they found the change in the horizontal to the vertical. It's supposed to be the other way around, vertical on top. So to find our slope here, we should be doing 10 minus -2 over top of 8 minus 8. So 10 minus -2 is 12, and 8 minus 8 is 0. Oh goodness, that's not good. So the run is 0, so the slope is undefined. So remember, vertical lines have an undefined slope, and horizontal lines have a slope of 0. So slope is supposed to be the steepness of the line. So this is a slope of 0 because it's flat. But when we draw the other way, vertical line, this has a slope of undefined. It's too steep to give it a number. Okay, it has no over. All right. So check off the vocabulary words that you understand. It should be a straight review from Algebra 1, so you should be pretty good with slope intercept form, and point slope form. And if you're having trouble with this, so you're not in that 8-10 range, you'll want to come to class next time, get lots of help, and then possibly schedule a time to stay after school or an advisory to come by and practice some more. Okay, so this meant to be a quick review of some stuff that we did in Algebra 1. All right, see you in class next time. time.